Good morning, this is Dr. Turner for Integrated Math 3. Today we're going to be talking about 9.5. 9.5 is the last of Unit 9 and we are looking at transforming trigonometric functions. In 9.4 we just talked about the basics, what does a sine or a cosine or a tangent graph look like, but now knowing that we want to be able to shift it. We've done this with linear functions, exponential functions, quadratic functions, all different types of function families at this point, and the process is going to be very similar for trigonometric functions in terms of shifting it up or down, in terms of making it wider or more narrow. It's going to look very similar to every other type of transformation we've done so far. Okay, so let's go ahead and get started here. We'll start out with just your sine function. Okay. So for your sine function, again, it is oscillating. Sine function has an amplitude by default of 1 and has a period of 2 pi. It takes 2 pi to complete a cycle of the wave. Just like any other function family, if we change the output, it's going to move the graph up or down, and if we change the input with an inverse sine, it's going to move the graph left and right. The parent function for sine is, of course, sine x, but just like with quadratics, if we're looking to transform the function, typically we write it out a little bit, and so the parent function for both sine and cosine is given as a times sine of bx plus c, where that's all in parentheses, plus d. Okay. Okay. So d serves as the change in our output value. It's a value we're changing on the outside. And so by moving the d or shifting the d, it's going to shift the graph up or down. So there's y equals sine x, and changing it to sine x plus 1, or 2, or 3 would move that graph up. And vice versa, minus 1, minus 2, minus 3 would move the graph down. If we change the c value, that's changing the input, and so that's going to change it to move it up, or sorry, left or right. Now, you could put a minus 1 or a minus 2 in there to move it left and right by that amount, but typically if you're talking about a transformation of a trigonometric function, any horizontal shift is going to be in terms of pi because we've changed our scale to be in terms of pi. So I might have something here like minus pi over 2, okay? For instance. So just like with all the other function families that we've seen, right, even though it's a minus sign, it's moving it to the right. So minus pi over 2 would move the graph right pi over 2 spaces. Minus pi would move the graph right pi spaces. Minus pi over 4 would move it right pi over 4 spaces. And vice versa. If I wanted to move it to the left, then I would need a plus here. So plus pi over 4 moves it left that many spaces. Plus pi over 2 moves it left that many spaces. Plus pi moves it left that many spaces, etc., etc. Of course, with Desmos, you can always put in the little sliders here. So if you just typed in on a regular line, a sine bx plus c plus d, it'll give you the option to add in those sliders, and then you can play with them as you'd like. For instance, if you type in d, you can play with how each of these variables will change your graph, right? Just like any other graph with Desmos. Those sliders help you visually see how each of them changes. Okay, so that moves your graph up, down, left, and right. What the a value is going to do, just like any other function, is that it's going to change how quickly the graph is increasing or decreasing, but more specifically, because it's a sine function that oscillates between 1 and -1, an a value change is going to change the amplitude of your sine and cosine graphs. So for instance, sine of x compared to 2 sine of x changes the amplitude to 2 instead of 1. So it's going higher and lower than the standard graph. 3 sine of x, 4 sine of x, 5 sine of x increases the amplitude to be that value. You could also decrease a, so for instance 1/2 would go between positive and negative 1/2. Positive 1/4 would go between positive and negative 1/4, etc. Just like any other function family, if I change the leading coefficient to be negative, it flips my graph upside down. Okay. And then lastly, your b coefficient, what that does is it's going to increase the speed at which you're completing a wave. So by default, your wavelength for sine and cosine, that's 2 pi. If you were to change it to 2x, then it's increasing faster, and therefore you would complete a wave in pi units instead of 2 pi units. So whatever the b value is, and you don't need to do this for the graph because you're using Desmos primarily, but to determine what your period is, or the length of the wave, what you would be doing is you'd be taking 2 pi and then you would divide it by whatever your b value is. Similarly, if you were to decrease your b value, let's say you change this to be 1/2 x, then it would take twice as long. It would take 4 pi to complete a period or to complete a wavelength rather than just 2 pi. All of these properties are going to be true for both sine and cosine. So if you look at cosine x, for instance, versus cosine of 1/2 x, it's going to be the same thing. All the changes will be similar in terms of moving it up and down, in terms of moving it left or right, and in terms of changing your amplitude. All the same changes apply to both sine and cosine. That's it for today, guys. If you have any questions, please reach out to me. Otherwise, have a good day, and I will talk to you soon. Bye.